Hello people, I hope you have a nice day. In this video I want to show you how I created the deformation effect on cars like in my previous videos. And all of that in blueprints, no coding required. Have a look at what you can achieve after this tutorial. You might add some extra work though. Okay, now I want to talk about the techniques I used, what the advantages and disadvantages are. At the core, the built-in procedural mesh component is responsible for most of the work. Through it, it is possible to build and manipulate meshes at runtime. This flexibility was the reason why I chose this approach over all the others. Epic, for example, uses skeletal meshes in their Matrix demo. While the performance and mesh complexity may profit from this, it is a tedious task to rig every model by hand. On the downside, the procedural mesh component isn't very performant. I haven't found a way other than to loop through every vertex and compare the distance to the one of the hit point. This means that the meshes used for the vehicles, or every other case you may find this useful in, can't have too many polygons, but you also can't have too many of those blueprints in your level and active at the same time. Otherwise, you may fry your CPU, or what's more likely, crash the engine. For some more beauty, the vertex colors are colored the same time as each vertex is deformed. I used the red channel and later had access to it in the material. I only used one material, instance, and one mesh in this case, but it's definitely possible to use more. Anyways, with the vertex colors, I blended between an undamaged and busted albedo map, but also made a wrinkled normal map appear for a little more detail. By the way, I used the advanced vehicles system from 747 for the driving mechanics and physics of the car. This isn't mandatory though. I only choose it because the setup is quite easy and I got it for free a while back. Sadly, this plugin has also a major drawback, which I'll talk about later. I got the model from the generic passenger car pack, which you can see here. I'll probably put the exact model and materials I used in the description as a downloadable link because I had some merging to do before using any of the models. So, now that all this info is out of the way, let's start creating the parent blueprint. Links to the blueprints on blueprintue.com are also in the description. Let's begin with adding everything we need, which isn't much. Only the PMC and a spring arm with a camera attached to it. The later is optional, as I will focus mainly on the deformation part here. Then create all the variables we need to manipulate the mesh and reset it if we wanted to. I won't go over every one of them. You can see what we need. If you aren't as experienced with blueprints, the checkerboard pattern means the variable is an array. We only need to expose the static mesh and material variables, as we need to change them later on in the children. In the construction script, we'll store all the initial values for future processing. Looping through every vertex assures us to have the correct amount of vertex colors. Then the variables are assigned their corresponding values, outputted by the getSection from static mesh node. In the end, the procedural mesh component is created from that data and assigned its material. The problem with the AVS plugin is that it has to use the collision of a static mesh. Sadly, in that way, you can't make use of the dynamic recalculation of collisions of the PMC. After adding a on-component hit event on the main collider, remember to check simulation generates hit events, or else it won't work. The first thing to do is to calculate the strength of the impact. Depending on if the other component that has been hit is simulating physics, its velocity and mass will be considered. Then, these values are offset against the cars. I set a threshold of 0.03, which has to be exceeded. The do once node will ensure not to do the calculations too often, just for safety so your PC doesn't explode. We have to create two functions, one for getting all the points inside a certain radius and another to do all the changes to the selected vertices. Getting all the points isn't too complicated really. We're looping through all the points we previously stored inside the vertices variable, compare its distance to the hit point, and then also adding an element to the output array for looking up the strength by which it has to be deformed by. For that, the distance is divided by the radius. That result is squared, inverted, and offset by 1. Here you can see what the corresponding graph looks like. Now all the changes to the mesh can be made. Again, a for loop is used to go through all the found points. The variable which contains the vertices to build the mesh is then changed. Subtracting its position by the deform strength times the impact strength times the original position will us give the result we want to achieve. Keep in mind, though, that this will result in deformation towards the vehicle's center. I tried to deform them with the hit vector, but got no feasible result so far. Maybe you can find a solution to that. If you do, let me know in the comments. Afterwards, something is added to the red vertex colors channel value, if we want to at least. Okay, so that's all the hard work we had to do inside the blueprint. Now, the mesh section only has to be updated and the do once node with a delay reset. I chose a value of 0.25 seconds. The play sound at location as well as the reposition wheels after impact are optional. If you want to know more about the latter, have a look in the video description. Now, to the material. The red vertex color we previously set inside the blueprint is now used to interpolate between the intact and damaged albedo of the vehicle. With the multiply and clamp node, the transition can be hardened because a soft transition looks rather unnatural. The same output is then used for the blending of the bumpy normal map as well. The name of the normal map is T_water. Normal 0, 1_n. It should come with your project. The rest is pretty much standard material stuff. Specular, metallic, and everything else you want to change. Finally, we have to create a child blueprint class. Give it a name you like and open it. We only have to assign our mesh and the material. If you also use the AVS plugin, you can now add the wheels and all the other things. Then drop the BP in the level and choose Player 0 for the auto-possess player in the details menu. Have fun driving around? As I said earlier, I mainly focused on the process of deformation. How you can make the car drivable has to be looked up in another tutorial. I'll link some helpful articles in the description if you have trouble with that. I hope this tutorial was somewhat helpful and interesting. Feel free to ask me anything in the comments. Bien!